Hello again, guys. So this is going to be question 5 onwards. So question 5, this looks a really overwhelming question. It's not. A lot of it is you interpreting what the model is and trying to figure out what the initial value is, etc. There's not a lot of calculations here. So if we look at the very first question, it asks us to put the initial volume of water in the tank. So you just get 1 mark for this. Now, you can write it straight down, but I'm going to show you how we work it out. So the initial volume is what happens at t equals 0. So at t equals 0, if I was to plug 0 in here, you would end up with e to the 0, that would give you 1. So the volume would be 5 cubic meters. So that's how much is initially in there. But you could definitely just look at that and write down 5. It's only 1 mark and it's a B1 mark. So it means what you see is what you get. You have to have that written down. Okay, the second part, this is where there's a little bit of calculation. So part 2, it asks us to work out the time when the volume of the water is 2. So the volume is now 2. So I'm just going to plug these numbers in. And we don't know what t is, so we're trying to get at this t here. And we know when we're trying to get it to power, it's going to involve logarithms. And because I'm dealing with e here, it's going to involve the natural logarithm. So I'm going to do a little bit of rearranging here. I've got to get rid of that 5 first, because if I try and learn something, I can't do it with a number in front. So that's what I've got. From here, I'm going to move up here. I'm now going to take the natural logarithm of both sides, because I'm dealing with e, remember. And now to get at t, I'm just going to plug this all into the calculator, divide it all by negative 0.14. It doesn't look pretty, it doesn't have to look pretty. I get 6.54 minutes. And it doesn't say anything about seconds or whatever, so I'm not expecting you to tell me how many seconds, how many microseconds, etc. Okay, marks here. So you get a method mark. Your first one is here, actually, for getting it into the form where you've used learn. And then you get an accuracy one for the answer. You don't get any up to that point, unfortunately, because that's not difficult. But your first mark is there to know, for knowing you have to take the natural logarithm. Okay, I'm just going to delete some of this so I've got some space. Okay, part B, these are some questions now about how we can refine the model. So B part I. Suggest how the model can be refined. So the initial volume is double. Okay, well, this is easy. At the moment, it's got a volume of 5 initially, so just replace the 5 with 10. There we go. Okay, part 2. And that's just worth 1 mark. It's a B mark. All of these are B marks. The rate of flow out of the water is slower. So the rate of flow is this bit here. And if we want to slow it down, we're going to expect that 0.14, which is in front of the t, not the negative, that tells us it's decreasing, but that 0.14, if that was smaller, it would come out of the tank even slower. So replace 0.14 with this smaller number. Okay, you're not replacing the negative, you are replacing the actual number. And state one limitation. Or tell me if you've got other ones. There was just one obvious one to me. As t approaches infinity, you are never actually going to empty that tank. So the volume is going to get closer and closer to 0. And this is a big problem with a lot of mathematical models. In real life, they fail So as t approaches infinity, the volume approaches naught, but is never actually 0. So that tank is always going to have the tiniest bit of water in it that you can't get rid of. Okay, B1 mark, B1 mark, B1 mark. There are alternative answers. Excuse me. So mine are not the only one. You've got to have something like that, talking about doubling the 5. You've got to make that number smaller, and that might have been in different words. There's a couple of other limitations you could have, but that one's the obvious one. If you are unsure if what you've put is right, just drop me an email and I'll have a look at it. Now, we've definitely done this question before. As soon as I saw it, I recognised it. So, question 6. Part A, I think I'll do it up here. Show that the radius of C2 is 3. Well, when you're trying to show something, you shouldn't really use 3. And that's a problem we had last time. You're not meant to use the information in a show that question. We've got 2 circles here. We've got one that's centred on the origin and one that's centred on 4, 3. And from this, we can tell that the radius of this one is 2. And using Pythagoras, we can easily work out the hypotenuse there. So we've got this triangle there. I don't know if you can make it out very easily on my awful drawing, but if that point's 4, 3, it means the base is 4 and the height is 3. Well, if that's the case, we know our Pythagorean triples, that must be 5. And because that's 5, it means that the length 5 minus the radius 2 must equal that. I'm just going to put there that that is the distance OM, and that is the radius of C1, just to make it obvious what I've done here. And the marks awarded, you get 1 mark for working out that distance 5 there. You get a B1 mark for just stating that the radius is 2. And then you get 1 mark for trying to do this kind of calculation over here. Okay, so 3 marks there. Part B is lovely. It's just writing down the equation of the circle. Well, we know the radius is 3, and we know that the centre is 4, 3. So we can plug the centre straight in. And then 3 squared will be 9. There we go. And you get a B1 mark for plugging in your centre. And you get a B1 mark for the radius. And the B marks, because it can't be anything else. They've given you 4, 3, so there's no reason for you to use anything other than 4, 3. And because they've told you here it's 3, you haven't got any follow-through marks. In another kind of question, if you got the wrong radius, you'd get a follow-through mark for that. But you've been told here that the radius is 3. Okay. Write down the coordinates of n. Well, this is not a difficult one. It's a really stupid question, actually. I don't understand why they've put it in here. I can clearly see from here that if that's 4 up there, that's going to be 4 there, and it's on the axis. So what else can it be? It is only a 1 marker. It's a B1 mark. So something that initially started off as looking like a really challenging question is one of the easiest questions I've ever seen. Okay, question 7. A little bit unpleasant. You know, they've not been kind there, have they? And if we look at A, they are trying to help us here. They're trying to help us with part B by getting us to write part A in the right form. So they are leading us into part B here, which is quite nice. So part A, they want us to write that in the form of 10x to the p minus 5x to the q. So they're giving you a big hint here that at the moment you cannot differentiate that because it's in the wrong form. Okay, so my first step would be to split the two fractions up. And I did not like what was written on the bottom at all. I really didn't find it pleasant that they've written root x to the 7. Well, square root, remember, is x to the half. So the square root of x to the 7 is x to the 7 over 2. And I think you'll agree it looks a little bit nicer to deal with. So that's my first step there. From here, remember your your index laws. When you divide, you subtract the powers. So I've got an x squared up here, x to the 7 over 2. So when I divide these, I'm going to end up with 10x to the minus 3 over 2. And I'm leaving it up the top for two reasons. One, that is what is suggested in the answer. But when I differentiate it, I don't want to have 10 over x to the 3 over 2. I want it all on one line. Take away, up here I've got root x, which is x to the half. X to the half divided by x to the 7 over 2, you take away the powers. And we get 5x to the minus 3. And it says where p and q are numbers to be found. So I'm going to state that p equals minus 3 over 2 and q equals minus 3. You don't necessarily have to do that, but it is good practice. And you get 1 mark for both of those. It doesn't seem a lot of marks for what you've had to do there, but it is only using index laws from GCSE. If you'd have not written this bit, by the way, they would have picked it out from here and given you the marks anyway. Okay, so it doesn't have to be specific like I've done it. Okay, part B. It's talking about here maximum points. And as soon as you see anything about maximum points, minimum points, you should be thinking, okay, so that's when your gradient is 0. So even if you don't fully understand the question, there's, little hints in a question that tell you what to do. So part B, the first thing we need to do is differentiate this. Because I'm dealing with f of x, I'm going to stick with that notation and do f dash of x. So when I differentiate this, remember the power comes down and you've got a calculator, but that comes down and multiplies. So you're doing negative 3 over 2 times 10. Well, that's negative 15. And then we'll also be doing the negative 3 times the 5 there. So that gives me minus 15 x to the minus 5 over 2 plus 15x to the minus 4. Now marks here, you get a method mark and an accuracy mark for differentiating them. One for attempting to differentiate it and one for doing it correctly. Now from here, if we are trying to find maximum points, we need to set the gradient equal to 0. And be very specific about this. Tell the examiner what you are doing. So you are putting it equal to 0 for stationary points. Now from here, I've divided the whole thing by 15. I've put them on different sides to each other. So I had x to the minus 5 over 2 equals x to the minus 4. I ended up with x to the 3 over 2 equals 1, which means that x equals 1. You may have done it slightly different, that's fine. So you get one method mark here for putting it equal to 0, and then an accuracy mark down here. And now just looking back at the question, it's saying work out the coordinates of the maximum point. Okay, well, I've worked out x equals 1. I haven't found y, have I? So when x equals 1, be very careful. You're not plugging your x back into here. If you do, you'll just get 0 out. You want the y coordinate. So you put an x back into your original f of x. So y equals 10 times 1 to the minus 3 over 2 minus 5, 1 to the minus 3. So I've plugged it back into there, my simplified version, and I get 5. So my coordinates are 1, 5, and that's where my last mark is. Okay, lovely. Now, part C, a bit of a weird one here. It's saying find the set of values of k for which the curve and the line intersect once. I remember this wasn't done particularly well because it wasn't understood that y equals k will just be a horizontal line. Let me just get rid of some of this so I've got some space and I can make the diagram a bit bigger. Okay, so we've got y equals k here. Let me make this a bit bigger. Okay, so we've got some horizontal lines here. Now if I draw a horizontal line across here, it's going to cut twice, so that's no good. If I draw a line right at the peak there, it is only going to cut once. It's going to have a repeated point there, but it will only be 1. And if I have my line, sorry, I lost my trail of thought then because I paused it, I can't remember what I was saying. I think I said, and if I have my line down here, I'm just going to shade it, it will only cross once. So this curve will keep going on and on and on and on, but it won't actually fall below the axis. So I want my line to be either up here, and I need to figure out what is that value up there. Well, I've just found it. I worked out the coordinates of the maximum point and they were 1, 5. So that means the y coordinate there would be 5. And down here, if that curve goes on forever and ever but doesn't fall below the axis, then any line down here would also only cross once. And that line there is y equals 0. So our answer is going to be, we want either k to be 0, or it could be anything below the axis, or if k equals 5, it would cross up here. If k was greater than 5, it wouldn't cross at all. So up here we've got k equals 5. Down here we've got k equals to 0, but anything below it would also satisfy. And I think in the question it talks about set notation. Yes, it does. It says find the set of values. Okay, so we get 1 mark for having these values up here. We get an accuracy mark for doing the set notation. So set notation is squiggly brackets, and we're saying, right, k belongs to the set of real values, dot dot, k is less than or equal to 0, or k belongs to the set of real values and k could be equal to 5. And that's our accuracy 1 mark there for the set notation. Okay, binomial expansion. Part A. I know you're given a formula in the formula book. I'm not a fan of it, especially when I don't have to use it. So I'm not going to do Pascal's triangle. I don't really want to draw 10 rows. I'm just going to use the NCR button on my calculator. So it's going to be 10C1, 10C2 and 10C3. I want ascending powers of x up to including x squared. And remember here, brackets are key. So because I'm doing ascending, that is meant to be a 0, by the way, not a 6. Brackets are hugely important, otherwise you forget to square the bottom or square the top. And as this is increasing, the other one is decreasing. Okay, so that gives me 1, that gives me 1, 10C1, also 1. Next one, sorry guys, again I lost my train of thought. 10C2 times by x, and then 3 to the 1 as well, don't forget that, 1 to the 9. So that would give me 10 over 3x plus 10C3 x squared over 9 times by 1. So that gives me 5x squared plus dot dot dot. So if you've got those wrong, chances are you forgot to do x squared and 3 squared here. Okay? And your marks, you get 1 mark for that 1 there. It's got to be as it's seen. You get a method mark for attempting those 2, and an accuracy mark if one of them's correct. And then you get an accuracy mark if they are all correct. Right, part B. Find an estimate for the value of 1.021 to the 10. Okay, so let's compare these two, because they look a bit similar, don't they? Kind of. So I need to figure out what value of x makes these two equal. And it is x equals 0.063. So you get a couple of marks here. You get a method mark for knowing to put those two equal. And then what we're going to do from here, if this is your value of x, I'm going to plug that into the expansion and see what I get. I'll do it up here. So if x equals 0.063, I'm going to do 1 plus 10 over 3, 0.063, plus 5 lots of 0.063 squared. And that gives me 1.2298. And the marks here, I get a method mark for substituting my value in. So if your value is wrong, you still get a method mark there if you've done it accurately, but you don't get the accuracy mark at the end. And part C, how could you make it more accurate? Well, just use more terms. Okay, question 9. Quite a weird question, I'm not going to lie. You've been given the curve f of x, and you've got 3 turning points here, P, Q and R. You need to sketch the gradient function. So there's a couple of things you need to remember here. So if your gradient, so it's really bad writing, if your gradient is increasing, so like it is here, your curve's going up, so the gradient is going up. So that means your gradient will be positive. That means f dash of x will be above the x-axis. If your gradient is decreasing, wow, apologies for that. So here, your gradient's going downhill, then that means that is going to be below the axis because it would be negative, okay? So if your gradient is increasing, then your f dash of x will be above the x-axis in this area here because it will be positive. Where your gradient is decreasing, we're going to have f dash of x being below the axis because it would have a negative value. And where your gradient is 0, it will intersect the x-axis. So the first thing I'm going to do is put a mark where it's going to cross the axis. So everywhere I've got a flat gradient, so here, here and here, where the turning points are, that's where the gradient will be 0. So my gradient is going to cross there, there and there, and that's actually where your first mark comes from, okay? So you get a B1 mark for crossing at 1, 2 and 3. So now I have to try and fill in the rest here. Well, the gradient here is increasing, so I know it's going to be above the curve, above the axis, sorry. But here it's going downhill. So from here to here is going to be below the axis. Okay, so up here is going to be above, then here to here is going to fall below. Then it starts to increase. So from here to here is going to be above again. And I only need to go up to 3. But if I went further, when I get here and it starts to decrease, it would fall below again. So now I know that, I need to try and make it work. So it's going to start to increase here. So I need to draw some kind of a loop down here, and that's going to end up going up there. And then between here to here, it's increasing, so it all needs to be above. So it'll be something like that, okay? So where your curve is going up and the gradient's increasing, my line's going to be above the axis. Wherever it starts to decrease, I'm going to have a curve below. It needed to curve like that because it was coming back up to intersect. Here to here, it was increasing, so it's all going to be above the curve. If I went further, here starts to decline, so it would fall below again. I hope that makes sense. I'm going to stop this video here because it's getting quite long, and questions 10 onwards will be on the 3rd video.